Hi, in this video we're going to talk about the ambiguous case. So the ambiguous case is what happens when we're in trigonometry and we're trying to solve a triangle, but we're given information about that triangle that actually means that we can draw it out in two different ways. So you'll be given two sides and an angle. So one side is the opposite side of your angle. You're given an angle and just one more side of the triangle. So since we have an opposite side of the angle, that means that we can use sine law in solving that triangle. However, first we have to draw the triangle, and it might be possible that there are two triangles we can draw with that information. So let's have a look at what that actually looks like. So here is a demonstration that was created on GeoGebra by Brothen_1. And what we have is a triangle that has an angle of 27 degrees. One side is 6.7 units long, and the other side is 4 units long. So we see here that we have one triangle over here that has a side 6.7 units long and another side that's 4 units long with an angle of 27 degrees. But there's also this other triangle in red that has the same characteristics. So this is an example of an ambiguous case. So if I wanted to solve this triangle, well, I'd get answers for solving the whole triangle, and I'd also get different answers for solving just this first triangle as well. So let's have a look at what happens when I start playing around with the given side. So let's say that my side that I'm given, our first case is, let's suppose the opposite side is bigger than the given side. So I have my opposite side is 4 and my given side is 6. So let's make the opposite side bigger. So notice when I drag this over, once it equals 4, once they're equal to each other, well, suddenly, oh, there it is, close. Once they're equal to each other, then only one triangle emerges. So as soon as the opposite side becomes bigger than the given side over here, I'm only able to have one triangle. So the ambiguous case kind of goes away. So if your opposite side is bigger, then there's only one triangle. Only one triangle. Next case I want to look at is what happens when the opposite side is smaller than the height of the triangle. So our height of the triangle, make this back to 6. Here we go. So the height of the triangle, when this side is 6.7, close to 6.7, is this over here. It's that vertical distance between the top point of the triangle and the opposite side. It's perpendicular to the opposite side, right? So the height of this triangle we can actually find by doing the sine. Like this side is the opposite side, and we know our hypotenuse. So the sine of the angle 27 degrees is going to equal this height divided by 6.7, the hypotenuse of that triangle there, creating a right angle triangle in the middle. So that height has to be, in this case, it's automatically calculated for us. Our height of this triangle is 3. So if we made the height of that triangle bigger than our opposite side, right? If our opposite side suddenly becomes smaller than our height, so if I drag this up more and more, at a certain point, it becomes bigger than the height of the triangle, right? So all of a sudden, for example, when the given side is 9.2, my opposite side is 4, well, the height of the triangle is 4.18. So that side is no longer long enough to actually reach the opposite side, and your triangle can't form. So when the opposite side is less than the height of the triangle, there is no triangle. There's no triangle at all. Sides don't reach. Oh, spelled reach wrong. Right? And then there's case 3, which is when the opposite side of the angle that's given is smaller than the given side and bigger than the height. And kind of shown you this already. So when that happens, what we get is 2 triangles. And when that happens, we actually need to solve for both triangles. So when this occurs, there are 2, well, I'll spell it out in words, 2 triangles. And this is the ambiguous case. So let's have an example of how do I actually solve a question that is the ambiguous case. Here I have an example for triangle ABC. One side is 3 centimeters, another side is 5 centimeters, and then angle A, which is opposite of little a, is 30 degrees. And it says solve the triangle or triangles. So we know that 2 sides and an angle opposite to one side are given. This is an ambiguous case of the sine law, where the given angle is acute. Our given angle is 30 degrees. If you remember, acute means it's less than 90 degrees. So we have to first do our first step. So our first step, actually, let's write this in a different color. Our first step is to check if we actually have a triangle, right? So first we have to check if one of our sides, well, we already know that side A is smaller than the given side. So automatically we know that we either have no triangle or 2 triangles, right? Because our given side is smaller than the opposite side. So all I have to check to see is if the opposite side is bigger than the height. So I'm going to look for the height of the triangle, and that's going to equal the opposite side times sine of 30. So the height of this triangle is going to be 5 sine of 30. And I need to actually calculate that height first. And I'm just going to compare it to the opposite side. So first my height. I do 5 sine 30. The height of the triangle is 2.5 centimeters, right? So since the height of the triangle is smaller, A is bigger than the height. Therefore, we have 2 triangles. Now that I've checked that that a triangle can indeed form, now I'm going to start solving it. So step 2, I'm going to draw out my 2 triangles. So one triangle, it's not going to be to scale, by the way. So one triangle is going to be going to the right of the height of my triangle, and the other triangle is going to be going to the left of the height of my triangle, right? So my triangle's height is here. This is my triangle's height. So I either go to the right of the triangle, and this is side A, which is 3 centimeters, or I go to the left of the height of the triangle, and that side is also 3 centimeters. That kind of makes it look like the height is 3 centimeters. I'm going to do a little arrow, tell you guys that this is 3.0 centimeters. And this side is 3.0 centimeters. So that's side A. Angle A, this is 30 degrees. This one is 30 degrees. And my remaining side, C, is 5 centimeters. And what I don't know is I don't know what side B is. So this is angle B This is angle C, angle B, and I don't know what side B is, and I don't know what angle B or angle C is. So if I want to solve this triangle, I need to look for angle B and angle C. So in this first triangle, let's call this triangle 1, and let's call this triangle 2. So in triangle 1, C is definitely going to be acute because I'm going to the right of my 90 degree here. B might be obtuse. I don't necessarily know that yet, but it's possible that B is obtuse, but C is definitely going to be acute here. However, if I go to the left of my height over, like in triangle 2, C is definitely going to be obtuse. So I need to find, whenever I'm solving for a triangle using sine law, I need to find the biggest angle, or the one that's most likely to be obtuse, last, right? So here I need to solve for B last. And here I need to solve for C last, but we're actually going to be able to solve for C once we have solved for C in the triangle 1. So I'm just going to solve triangle 1 first. Let's have a look at that. So first, let's look for angle C. So to find angle C, I'm going to use sine law. So the sine of C over 5 centimeters, its opposite side, is equal to the sine of 30 divided by its opposite side, which is 3.0 centimeters. So C is going to be the inverse sine of 5 times sine 30 divided by 3. So when I plug this into my calculator, I'm going to round it also to the nearest degree. So I'm going to do inverse sine times 5 sine 30 divided by 3, and I get an answer of 56 degrees. So C here is 56 degrees. Now, if C is 56 degrees in one direction, right? So if I went in one direction, and this is 56 degrees, and I know that this is 3 centimeters, if I went in the opposite direction, also 3 centimeters, well then I know that this angle is also 56 degrees, which means that this obtuse angle right here, that's got to be the remainder. So that one's got to be 180 minus 56 degrees. So angle C in the other triangle, 180 minus 56, this one is 124 degrees. So this angle over here, this one's going to be 124 degrees. So just like that, I've already found two of my angles in both of the triangles. So that means I can automatically find angle B as well. So angle B in this case is going to be, oh, my 4 didn't write. This one's going to be 180 minus 30 minus 124. So B here is going to be 26 degrees. And over here, B is going to be 180 minus 30 minus 56. So B here, that one is going to be 94 degrees. So look at that. B actually did happen to be obtuse in this triangle. So this one's 94 degrees. It's not always necessarily going to be obtuse, but it's likely. So it's a good idea to solve B last just in case we get stuck that way. All right. So I'm also going to label my B angle over here, which is 26 degrees. All right, so now I have angle B on both the triangles. Now all that's left is to find to find the last side B. So if I'm solving it in my first triangle, side B divided by the sine of 94, That's going to equal 3 centimeters divided by the sine of 30. So B is equal to 3 times sine of 94 divided by sine of 30. So our side B, 3 sine 94 divided by sine of 30, that's equal to 5.985 centimeters. So if I am rounding to 1 decimal place, this is actually 6.0 centimeters. So B over here is 6.0 centimeters. And in this last triangle, B over the sine of 26 is going to equal the 3 divided by the sine of 30. So B here equals 3 sine 26 divided by sine of 30. 3 sine of 26 divided by sine of 30. Well, that equals 2.6 centimeters. So that's this one over here. 2.6 centimeters. All right, so that's how we solve for the ambiguous case. In my next video, I will show you an example of what happens when you're given two sides and the angle opposite is not acute. What happens when it is obtuse?